Are we on? I think we're on. Okay, let's do this. Guys, today we're going to talk about building recursive data flows. But this isn't going to be your average tutorial. I'm going to talk about everything there is to know about building recursive data flows the right way. And if you've watched my channel, you know I have pretty strong opinions about how to do things properly in Domo. But I say the right way, having seen no less than 3 posts in the dojo today about recursive data flows, where people were kind of confused about what the data flow was doing. And then also in one of the posts I was looking over, people were straight up using the data flows or recursive data flows incorrectly. And you might say, Jay, how is it possible to use a recursive data flow incorrectly? Well, I think in order to understand how to use it correctly, you kind of have to first understand what it does, be very clear about what a recursive data flow does, and then also make sure it aligns with your business requirement for the data. More on that in just a second. I'm super paranoid that my audio isn't working as intended, so I'm just gonna check and make sure that I'm actually recording audio. Am I? Yes. Okay, we can continue. I've done like 20 recordings of this, and each recording takes about half an hour, it feels like. So I'm like, oh, I gotta get this done. I gotta get it right. Here we go. Recursive data flows. So what does it do? First off, a recursive data flow builds history. Can I zoom in? Yes. Recursive data flows build history by keeping the most recent version of the row. Like, usually that's why people design or build recursive data flows. It's like, I'm getting data in a trickle and I want to append or I want to collect the most recent version of the row. And if there's historical data, I want to deduplicate it and remove it from my data set. And so I see a lot of people follow the KB article about creating a recursive snapshot ETL data flow, which is good. It gets the job done, but I don't think it's very extensible. And I think it's unnecessarily confusing. This is what the recursive data flow at the end of the day looks like. And let's just understand recursion. By definition, recursion in the context of data flows means to use the output as an input. Output, input. And by doing so, you're able to collect history. And as part of this data flow, what's going on here is we have our input, and I'm joining it to my historical data. And you're thinking, why would you do that? Well, in order to deduplicate the historical data, i.e. remove historical data that exists in my new data, I do the join and then I filter out cases where there was a match. This works. This gets the job done. But I'm going to show you a more efficient data flow that just uses 3 tiles instead of 7. And then we're going to extend it to make sure that no matter how you're using recursive data flows, you've thought through all of the little nooks and crannies of how your requirements might change and have a plan in place to meet your end user requirements. That's a pretty stiff promise, but we'll see. Now, if you haven't heard of Ralph Kimball, Google him, because all of business intelligence, like just the whole conversation, is built on the shoulders of his work from the 80s up to the late 90s. So you can't really talk about BI without talking about Ralph Kimball. And recursive data flows are a step, like dipping your toe into what are called slowly changing dimensions. So if you're working on expanding your knowledge in this space, I strongly recommend that you become familiar with some of the problems that the slowly changing dimension solves and some of its applications. Because half of BI, half of being good at Domo is just good pattern recognition. Being able to recognize, hey, that problem, that's the same as this other problem, but with different columns, different data. But the technique for how I solve the problem is the same. And so again, slowly changing dimensions is just type 1 SCD. Read about it and then debate me. All right, what we're gonna do though, is I'm gonna show you how to build type 1 and type 2 slowly changing dimensions and have a framework for extending into 3, 4, 5, and 6. If none of that means anything to you, that's okay. Just understand, we're going to figure out how to build really fast, efficient recursive data flows. The sample data that we're going to work with is kind of Salesforce type data. We'll have opportunities, they move through stages, they have a data modified date and an amount. Pretty straightforward stuff. But I'm using Salesforce, not because I love Salesforce, because everybody fundamentally understands sales. But it really nicely highlights where recursive data flows breaks down and where you need to start thinking about slowly changing dimensions. The key difference between the two is a recursive data flow just collects the most recent version of the row, whereas slowly change dimensions creates a new row to track anytime a column value changes, a specific column value, like you'll pick your columns. And the reason why this is important is if you want to talk about historical reporting with sales opportunities. If your question is, what is the current stage? How many opportunities do I have in each stage? That's fine with recursive data flows. But if your question is, on average, how many days do my opportunities stay in each stage? Or how long does it take to close an opportunity? If those are the types of historical analysis that you're trying to do, trend over time, which everybody says they want to do, you can't use recursive data flows. You have to use something else. So take a look at your use cases where you're applying recursive data flows and really ask yourself, do I need to analyze change over time? How a certain dimension value has changed over time, dimension attribute. It doesn't just have to be Salesforce though. It could also be, I don't know, like USPS. If your question is, how long does it take from a parcel to get from a mailbox into the hands of the recipient? How many stages does it go through? How many days does it take? How long does it take stay in each transit center? If that's your question, and I don't know why I could possibly be worried about the USPS right now, if that's your question, you can't just use recursive data flows, because recursive data flows will just say, what is the state of my parcel right now? And not answer, well, how long was it in stage 1, stage 2, stage 5? Same thing for, what was the other example? Inventory, manufacturing. If you're in manufacturing and you take something from raw material to finished good, you need to keep record every time the state of the product changes or the state of the workflow changes. And you can't do that with a recursive data flow. I mean, well, you can, everything's possible, right? But it might not be the concept that you have in your head for what a recursive data flow is supposed to do. So let's get started. I'm going to copy this data here, and let's pop into my ETL. And did I reset it? I did not. Okay, you can see I've got 4 output data sets because we're going to do 4 different data flows. This is going to be sick. You will know all of the different methods. Okay, by definition, a recursive data flow uses the output as the input. So the first thing we're going to do is pop in recursive history as an input data set. Now, somebody was complaining, they were like, hey, I don't like it that the output gets named _1. After I run it the first time, we'll be able to swap the names, don't worry about that. But recursive data flow. Step 1, append the data together. And then these guys, I'm just gonna disconnect them for now. Okay, so we're gonna append the data together, and we're going to do a straight append, but we're only going to include shared columns. Now, depending on your requirements, you might choose one or the other, but my recommendation is if you're accumulating history, wait or be sure that your schema isn't going to change much. Make sure that you're not adding and removing columns, because if you're accumulating history, some of the columns will have null data in it, and that just looks weird. So try to make sure your schema is stabilized, and I use only include shared columns as a way of forcing that to happen. Now, I am using Magic 2.0, which has some amazing quality of life features. So if you're not using Magic 2.0 yet, talk to your CSM. Make sure you have a good relationship with your customer success manager, because they can push some beta programs towards you that might be valuable to you. And Magic 2.0, in my opinion, makes it so there's no excuse for using MySQL or Redshift anymore. Like, if I can do it in Magic, I'm doing it in Magic, because it's just that good. And you're going to see that as we're working through this data flow. One of the nice things that Magic will do is it will help you handle data type collisions. So a data type collision is going to be like, if my input data set is amount is type integer, and the historical data set amount is type decimal. Decimal and integers are not the same thing, so Magic 1.0 would put them in two separate columns with a slightly different name, which isn't what I want, or it would drop the column entirely. Definitely not what I want. But Magic 2.0 will say, hey, these columns have the same name. I'm going to take my best guess, and I'm going to choose a data type that's compatible for both columns, which is super chill. But in the absence of that, even better, you can, during data ingestion into Magic, you can explicitly set the data type that it's going to be. So no matter what it's stored as in Vault, I'm always going to read the data into Magic as floating decimal. That's super cool. You would have had to use like the set data types transform or tile, but this gets it done in one step. What I also like about Magic 2.0 is that it introduces data handling for bad values. So you said the column should be type date, but this row here doesn't match date. So what do you want me to do? Error out the data flow, drop the row, replace it with a null? This is really cool, but be careful. Because if you automate data handling, but you don't have a way of reporting on the rows that were errors, then it's invisible to your ETL. And having invisible activity in Domo is, I think, never a good thing. All right. In any case, I will explicitly set the data type that I'm looking for. I do a straight append. Let's build our recursive data flow. Here we go. We're going to do it in 60 seconds or less. Time me. So what I want to do is I want to keep the most recent row of data. When you hear most recent, from now until the end of time, I want you to think window function. More specifically, I want you to think row number. So we're going to create a row number, and we're going to partition on the opportunity ID, because I want to have one row per opportunity, and I want to sort that by date descending to give me most recent. So basically what it'll do is say 1, 2, 3, 4, 5, anytime the opportunity ID is duplicated, where 1 is the most recent date. And I only want to keep the most recent row, so I will filter where the row version equals 1. Okay, that might have taken more than 60 seconds because I'm doing a ton of explaining, but that's your recursive data flow, this. So here we're going to do a straight append. I calculate the most recent by using a row number, and then I filter where most recent equals 1. Done. That's as opposed to like 7 steps here. I'm telling you. Just saying. Like, it's so easy, right? Okay, moving on. So that's your recursive data flow. I'm going to hook these all up for now. And we're going to do a save and run. Now think through the math. I've got 26. Sorry. Think through the math. I've got 26 rows in my history. I've got 26 rows of new data, even though they're both the same. When I append, 26 plus 26 is 52. Then I apply my most recent. Now, most recent is going to give row numbers 1, 2, 1, 2, 1, 2. for each duplicate opportunity ID. You can see here the values are the same and the row number is 1, 2, 1, 2, 1, 2. When I apply the filter to only keep row version 1, well, I only keep the most recent row. That's slowly changing dimensions in a nutshell. Check, done. Now, when you're doing slowly changing dimensions, if you're at that stage in your data pipeline, I strongly recommend that you also accumulate full history. Do accumulate full history. Recursive, remember, only keeps most recent. Why do I tell you to accumulate full history? Well, because someday you're going to be like, hey, remember when Jay was talking about I want to track change over time? I can't do that with recursive. It'd be nice if I had full history. If you do it now, you're set. If you wait, well, you don't have history. So do it now. It's super easy, guys. I could do this in 30 seconds, but it's going to take me longer to explain it. It didn't even take 30 seconds. I'm almost done. So when I'm trying to create full history, what you have to do is reframe what the table means. What is the granularity, or what does one row in the table represent? Granularity, one row in the table. They're synonymous. So granularity would say, I have one row per opportunity per day. You might say, Jay, why would I have one row per opportunity per day? Well, think about recursive. Recursive has one row per opportunity, the most recent row per opportunity. In full history, I don't want to just have the most recent. For each day, I want to have the most, if there's a transaction I want to have one row per day. I'm repeating myself and I feel like not necessarily adding clarity. We'll be there in just a second. So I'm going to add last modified to my partition because I want one row per opt per day. And then I have to define, okay, let's say I had 5 or 6 activities on the same day for one opportunity. Like it came in stage 1. And then I was super excited about this opportunity, so I made a couple of phone calls. I pushed it up to stage 2. And then the person I was talking to was like, yeah, we're closing today. I'll send you the check. I push it up to stage 3. Then they're like, oh, you know what? I can't get budget approved. But I promise you we're going to get it done by the end of the month. So then I set it back to stage 2. So I had several interactions on one opportunity in the same day. How do I store that in my full history data set? Do I store every single interaction, or do I only store one row per day? Now, let's assume that I agree. Let's agree we're only going to store one row per day. We'll talk more about that in a second. I have stage 1, 2, 3, and back to 2 again. Which stage do I keep? Do I keep stage 1? Do I keep stage 3? Or do I keep what it was at the end of the day? Given the data that I have, I can't tell you what it was at the end of the day because I don't have a date time column. My data at most is by date. And that's part of the reason why I'm defining full history as one row per opportunity per date. I can't make up the time. I can't tell you what time it came in at. I can guess, I can hope, but I can't guarantee. So that's why we're not going to use time. Now, what I could do is I could say, well, stage is ordered, stage 1, 2, 3, 4, 5. Now, I could say, well, I want to have the lowest stage because that was presumably, most likely, the stage when it started. Or I could say the highest stage, stage 3, which is technically closed. Depending on your business requirements, you're going to choose a different column for the order by clause. So like this is kind of up to you and understanding the business requirements. This is why you can't just follow blindly a KV article or a tutorial video for meeting your requirements. You do have to kind of think through this, and poking questions into business requirements is one of the things that I think a really good consultant, and I will be so bold as to put myself into that category. Like I do think that's one of the things that your developers should be doing when you're building out these data pipelines. In any case, I'm going to sort by stage ascending. I want to get the lowest stage. Cool, and that will be my full history table. Now, when I apply my filter, I don't have row version as a column anymore. The column should be called oh, sorry, I needed to rename it. Don't call it row version. We're going to call it row lowest daily stage. Cool. And then here, instead of filter on a column called row version, I'm going to filter on a column called lowest daily stage. But conceptually, it's the same thing, right? The only thing that's changing between recursive and full history is the group by clause. Opportunity ID and last modified versus most recent. And really, guys, that's the difference. That's it. That's the difference between recursive and full history. Well, that's a lie. We're not quite done yet. If you're implementing full history for the first time, then do run it off of your recursive data set. But before you can run it a second time, you must swap and not use not use recursive history as your input. You have to use full history as your input. So one more, oh so small, but very significant change. So I'm just going to do some quick renaming. I want my output data set to be called full history. I want my output data set to be called recursive history 1. Okay, good. So why am I building my full history recursive data flow off of full history? Well, because I want to accumulate full history, but not to use the word in the definition. Keep in mind, this data set will always only have at most 26 rows. Those 26 rows being the most recent version of the opportunity state, the opportunity row. I want to have all of the historical rows as well. So by definition, the recursive data flow cannot be used as an input. To illustrate this, I'm going to go ahead and save and run. Now, at the moment, all of my data sets should have 26, 26, and 26 rows. Like the data hasn't changed since the first raw load of data. But we're going to see what happens as I start pulling in new data into my data flow. Now, what's happening here is we're moving from August 20th to the next day of business, which is 9/1. And for most of the data, the stage is changing. So opportunity A moved from stage 1 to stage 2. Opportunity D moved from stage 1 to stage 2. Interesting. Opportunity G did not change stages. What happened here? Well, my AE, they got the opportunity from like the account development team. The account development team was like, man, it's just going to be peanuts, like 11 cents. That's all you're going to get out of this account. And the account executive, he made some phone calls. Like, no, I can push it up to 53. But I'm not ready to commit to changing the stage. The stage hasn't changed, but the amount has. Thinking back to slowly changing dimensions, remember, slowly changing dimensions keeps track of any time a certain column changes, and I'm setting you up for SCD. What I'm saying is, or what we're going to do is we're only going to track changes in the stage, but we're not going to track changes in the amount column. So how does that get handled in the output data set? That's kind of the interesting question, and that's what slowly changing dimensions gives for you. It gives you the ability to target specific columns of interest. Because like most of the times I don't care if your first name changed, like, or your last name changed, but I do care. I do care if the stage changed, or if your status changed, or the country you live in, or your account representative, whatever. I can cherry pick specific columns of interest to track and monitor, and I can build data sets for working with that requirement. And that's what slowly changing dimension tables does. We'll get there. For now, what we're going to do is we're going to load these 8 rows into our data set. Oh, and oh, by the way, for column Z, the date did not change. For whatever reason, the fact arrived late. This transaction came in late. The stage changed from 2 to 3, but the date did not. So maybe somebody like adjusted an entry or something. Who knows? You know those accountants, crazy journal postings stuff. I don't work in business. I just build data flows. Okay. Cool. So I have my most recent data. I can go back to my data flow. Right now, I've got 8 rows, 26 and 26. Let's talk through what we expect to happen. For recursive history, I run the data flow. Even though I have 8 new rows in this data set, recursive by definition only gives the most recent version of the opportunity. So I should end with 26 rows. For full history, you might say, well, Jay, you should get 26 plus 8 rows, which is 34. I should end up with 34 rows, but no, I won't end up with 34 rows. I'm going to end up with 33 rows because this is not a new row of data. There's 2 rows of data on August 20th, right here and here. There's 2 rows of data on August 20th, and by definition, I'm going to choose the row with the lower stage. So I'm going to end up keeping that row and discarding this row. And you might say, but Jay, that row's newer, you should keep the newer row. I have no way, after the data is appended, I have no way of tracking which row is newer or older. I could build that into the data flow, like with that where clause, the join on where, but I'm trying to avoid joining and just rely on the append. So what I would say back to you, my client, is I'd say, hey, if you want to sort the data by timestamp, I need a timestamp column. If you don't give me a timestamp column, can't do anything. Okay, let's run. So again, at the end of this ETL, recursive should still have 26. Full history should have 33. Recursive has 33. Sorry, full history has 33, and recursive has 26. So it's behaving as expected. Congratulations, we've implemented full history. If you are doing recursive data flows, you should do this. Just bare minimum, you should do that. Do collect full history, unless it's not valuable. If it's not valuable, right, that's a totally different conversation. But most days of the week, people will regret not having full history. Cool. So let's talk about now slowly changing dimensions. Remember, I want to track changes in the stage column. So let's put some fake data together here. Let's give ourselves, take this. I need to zoom out a little bit, guys. This is too close to my screen and I can't see everything. I'm going to do that. Oh, sorry, a bit of a mess. It was the longest possible. Oh, that took way too long. Okay. So here's my data. My column headings are opportunity, stage, date, and amount. So what I want to do is I only want to create a new row in the database if the row changed. Sorry, if the stage changed. So in order for me to look at one row and know if the stage changed, I have to know what was the value of the previous stage. Like eyeballing it, right? We can eyeball it, but I need to write a function that says, hey, put my opportunities, sort them in order, and take the preceding stage. I'm typing in null because if you're asking, hey, what was the preceding stage for this opportunity? Well, there was no preceding row, so this would be null. Okay, so I'm going to have to, one, implement some sort of a lag function, which is a window function, to calculate the previous stage. Then I'm going to have to build the logic that defines, is this a new stage? So how do you know if it's a new stage? If this does not equal that, then it's a new stage. Piece of pie. Now, for column A, for opportunity A, all of the opties, all of the rows were a new stage. That is correct. Now, for opti G, the second row is not a new stage because 1 is equal to 1. So the stage did not change from one row to the next. What did change from one row to the next was the amount, but we're not interested in tracking changes in the amount column. We're interested in tracking changes in the stage column. And that's what I meant when I said with slowly changing dimensions, you can keep track of every time a certain column changes. Our logic is defined by the stage columns. And so now all I have to do is add a filter that says keep cases where is new stage equals 1. Got it? Let's do it. So slowly changing dimension. First thing I want to do is I need to know what was the previous stage. So to do the previous, I'm going to do a window function. The previous stage, the lag of the stage offset 1 apply. Great. Next, what is my partition? I want to split up my data, or I want to partition my data by the opportunity ID. And then I want to sort the data by the last modified date ascending. Correct. So this will give me the previous stage. Now, after I have previous stage, I need to implement my logic that defines, is this a new row, a valid new row, or not? And I'm going to use a formula here. By the way, this is a Magic 2.0 enhancement, the ability to write formulas in Magic that looks like beast modes, or it looks like MySQL. What is this column called? Is new stage. So here, check this out. This is so cool. I can write a case statement inside of Magic, which is, I think, one of the reasons why people didn't like Magic was just you couldn't implement logic like this super easily and quickly. Like you can, but it's a pain. But now you have no excuse. Just use Magic. So case, when previous group, or sorry, previous stage is null, or when the previous stage does not equal the current stage, then 1 else 0. This is functionally the if statement that we wrote earlier. You just have to be careful on testing for null. You can't just have previous stage does not equal stage, because if the stage is null, sorry, if previous stage is null, you don't know what it is. So you can't conclusively know that it is or is not the same value. Just Google null handling in SQL. Okay, so previous stage and is new stage. Cool. Now the only thing we have to do is we just have to add our filter. To exclude cases, sorry, only include cases where is new stage equals 1. And that is my SCD1 complete. Now, what we did is we said, hey, you know what? I want to track changes on the previous stage column. If there were some additional columns that you want to track, like I want to track changes in previous stage, and I want to track changes in the rep that the opportunity is assigned to, then you would just add more columns here, right? You would add previous rep, right? Do the same thing, and then just extend this case statement for defining if it's a new row or not. So this is super extensible, and again, this is the reason why I like this design pattern so much better than the join and the where. Okay, let's take a look at our output. So in our full history, we get 32. In our version 1, we should get 32. Sorry, I said 32 twice. In my full history, I get 33 rows. In SCD version 1, I should get 32 rows. Because remember, for opportunity, let's say A, right? I have 2 cases where the stage changed, and that's correct. But for opportunity G, remember, the opportunity stage did not change between August 20th and September 1st. It stayed at stage 1, and only the amount changed. Now, this is actually setting us up for an interesting conversation, right? Our rule for inserting a new row in the table is if the stage changes, but the stage did not change. But you might say, you know what, though, Jay? The only reason why anybody's still working this account is because the current value is 53, not 12.12. I go into my actual data here. There are 2 rows of stage 1, and the value changes to 5375. What I want to do is I want to include 5375, not the 0.12. Now that's business logic, isn't it? And I can say, you know what? I can gracefully accept all of your requirement changes because I have full history. But if I didn't have full history, I'd say, well, you're kind of up the creek in terms of redefining your data collection requirements. But because we have full history, we can do whatever we want with solely changing dimensions. So let's extend out this model now to gracefully handle selecting the last row or the most recent row of each new stage group. And you heard me say most recent, so I know your brain is thinking, you want to do the rank like you did for the recursive data flow. But what are you going to apply the rank to? We need to create a column called new stage. Let's call it new stage group. And what that will be is it will be the cumulative sum of the is new stage column. So something like this. I'm taking the cumulative sum of this new stage. So 1 plus nothing is 1, 1 plus 1 is 2, 1 plus 1 plus 1 is 3. 1 plus nothing is 1, 1 plus 0 is still 1, 1 plus 0 plus 1 is 2. Just to illustrate what this would look like if I had a couple more like flip-flopping in stage 1. Okay, so imagine these dates are changing, but I'm not going to change them. But these are all stage 1, and like it started at 0.13, it was then 53, then it went up to 75, and then down to 0.23. Okay, or sorry, down to 23, whatever. So it's still stage 1, right? So in my is new stage, For all of these rows, it's still 0 because we're still in stage 1. The previous stage is all stage 1. And so for my cumulative sum, this is all 1. It's only after the is new stage has a new 1 that the cumulative sum upgrades to 2. Cumulative sum, like we all understand what that is. Jay, why are you spending so much time on this? That's fine. Cool. Let's implement this. What do I need to add? I need to add a new stage group. Great. And then I need to have a row version new group. That's going to say, hey, what is the version number of this row? Well, it's 1, 1, 1. But here, remember we did this in descending order when we did our recursive data flow to get the last one. So this would be a 1, 2, 3, and 4. I would keep this row. And this would be a 1 because there's no other values in this. This is just our most recent that we did in the recursive data flow. Pretty straightforward. The only thing that's new here is this idea of a cumulative sum. Piece of cake. Piece of cake. Stop. Stop. We are, hello? What you doing there, Sparky? We're gonna start here. So we're gonna create a cumulative sum. A cumulative sum is just another rank and window function. I'm killing these rank and window functions all over the place. They are relatively expensive. So if you can find clever ways to combine them or not use them, do so. But for this use case, some pretty good stuff happening here. What are we implementing? We are implementing the cumulative sum, which we're going to define as new stage. It is a cumulative sum. What am I taking the sum of? I'm taking the sum of my is new stage. And I want to use that to say, define the stage group. I can't think of a better way of describing it. So unbounded preceding and 0 following. This is what's referred to in windowed functions as framing. This is something you can literally Google, SQL, window function, framing, literally Google it. Or if you watch any of my tutorial videos about building beast modes with window functions, I've covered cumulative sum before, so this should look familiar. All right, so I'm creating a new column that's the cumulative sum of the new stage. Cumulative sum means go back to the beginning of the partition and don't include any rows after the current row that we're on. How do I define the partition? The partition is defined by the opportunity ID and the, sorry, I keep on trying to do this in the wrong place. It's just the cumulative sum is applied over the opportunity ID. And again, it's sorted by the last modified date ascending. Perfect. Now we want to do our most recent. Let me give this a name. This is our new stage. This is going to be our row version new stage. So again, it's going to be a window function. It's going to be a row number, just like we did in our recursive data flow. We partition by the opportunity ID and that new stage group column we just generated, order by last modified date, descending, because I want the most recent. All I've got to do now is filter on 1. And we're done. I am going to pop in a select clause just to clean up some of these utility columns I created. By the way, for those of you who decide to take a read into slowly changing dimensions, Kimball would recommend that you include a start date and an end date. How long was this row that I'm looking at valid for? And so start date, end date, you would just get the, depending on which way you're slicing, you would either get the lead date, so the date from the next row as your end date, or you would get the date from the preceding row as your start date. It's just another window function. Okay. Guys, this is it, we're done. Now, I'm 90% confident that this is going to work, but let's go over our four different tables. Recursive data flow, we already talked about, and I showed you how to implement it. Cleaner, better, faster, stronger recursive data flow using a append and a row number and a filter. 3 tiles instead of 7. Cake. Next, I recommended that you build full history, because slowly changing dimensions, your requirements will change. They will. That's just the nature of the business. So having full history will give you the ability to go back in time and change your requirements for slowly changing dimension tables. Slowly changing dimension tables, they're good. They're not required, because technically I have all of the same information in full history. I just have different subsets of data, right? They're built off of the same 33 row full history, but I'm choosing which set of rows I keep if I have that overlapping stage, right? The first row or the last row. And that's why they both say 32. It's because they both have the same number of rows, but what's treated differently will be seen when we look at opportunity G. This is not what I expected. Sorry, hold on. We did something wrong. Lag stage 1, sort by last modified ascending, and the opportunity ID. Dang it, what did I do? Sorry guys, give me 2 shakes. Oh, lols, sorry. I need to load more new data. So here's my third set of data, sorry. Oh. Okay. So we're running our third set of data. Sorry, that's why I didn't have the second stage for opportunity G. Let me just refresh here so these metrics update. Okay, as expected, recursive history has 26 rows. Full history, and again, I can build my slowly changing dimension table off of this data set. In fact, if I were implementing this data pipeline for a client, I would do one data pipeline that does recursive and full history, because it just makes sense to do both of those at the same time. Slowly changing dimensions are a type of table that are specific to a reporting requirement or an expectation of how data is visualized in the data mart. And so because that definition is going to be more fluid, I would tend to implement slowly changing dimensions as a separate data flow. That said, if we were talking about really, really, really big data volumes, like in excess of multiple tens of millions, even hundreds of millions of rows, if we're talking about really big data, I might put the slowly changing dimension data set in the same data flow as where I calculate the full load. Or again, I might try to have a different pipeline entirely, but this will work. Okay, so here's my full history. In full history, I can see the repetition of stage 1. And again, the question is, how do I handle it in stage 2, 5375? Okay, take note of that. In stage 1, we're keeping the first version of stage 1. And so because I'm keeping the first version, that ETL was a lot simpler. But for stage 1, August 20th, 12 cents. We said, depending on business requirements, I would want the second, or the last rather. I would want the most recent version of that stage 1 row. So in SCD2, we added 2 more ETL steps. Here, that gives me the most recent. And you might say, hey, you know what? I want a min and max. I want a minimum amount, maximum amount. Or I want a column that says how many different stages this group had. You can do all sorts of extension on this idea. And that, again, that's part of the argument for having that full history table. But really what I wanted to do, guys, is walk you through a better data flow model for this recursive snapshot. I wanted to introduce you to like ideas that might cause you to question whether or not this implementation is the right one. I wanted to introduce you to this idea of slowly changing dimensions, because here's the thing. With your recursive data flow, you're implementing a type 1 slowly changing dimension, which more or less says, give me the current version of this dimension. With type 2, we're introducing this ability to say, hey, over time, historically, what was the stage? What stage were we in on January 1st? What stage were we in on August 15th? Right? We're giving you the ability to ask that question over time. And then 3, 4, and upwards are different permutations of 0, 1, and 2. So keep that for your back pocket. Use this as kind of like a way of breaking into the larger world of BI. Impress your friends, but hopefully just make sure you're getting what you expect and what you want out of Domo. My name is Jay Wilson. I'm a freelance Domo consultant. This is what I do. I have my own company, Honest Reporting, that I use to help support clients, whether it's with implementation work or mentoring and training. Feel free to leave a comment in the YouTube video if you found this useful. And I really hope to hear from you guys soon. Catch you soon. Bye.